Hello everybody, this is Gigi from Kauai Community College. In this video, we will talk about integration by Trig substitution, and this is number 5 in the video sequence. So make sure you watch the other 4 before this one. Alright, so suppose you are interested in finding the integral of x squared over square root of 9 minus 25x squared dx. Okay, now the 9 minus 25x squared kind of give away the fact that we do need a right triangle, right? And the right triangle is like this, with the hypotenuse being 3 because it's 9 minus, right? So that must be the hypotenuse. You're looking for one of the legs, okay? And suppose this right here is 5x, and it must be 5x, so that 9 minus 25x squared, right, is the square root of that is the missing leg over here, 9 minus 25x squared. Okay, now when looking at this triangle, we would say sine of theta is going to equal to opposite over hypotenuse. So that would be 5x over 3, so that x is equal to 3/5 sine theta. That's one of the things that we need for our substitution. Okay, now if x is 3/5 sine theta, then we would say dx would be 3/5 cosine theta d theta. That's the dx, and we're going to need that for our substitution. And then we would say now the square root of 9 minus 25x squared. Let's which trig function is involving that? That would be cosine of theta. Cosine of theta is equal to, okay, adjacent over hypotenuse. So that would be square root of 9 minus 25x squared divided by 3, but I'm going to go ahead and multiply 3 up here. So then 3 cosine theta is the square root of 9 minus 25x squared. Those are all the things that we need for our substitution. So let's go back to our problem and plug everything in, right? So first x squared, so I know that I have to go and square this one. Okay, so that would be 9 over 25 sine square theta. Okay, and the denominator would be 3 cosine theta. And then the dx is 3/5, so times 3 over 5 cosine of theta d theta. Okay, so that's is what we have currently, and we can clean that up a little bit. Let's take a look on how we can clean that up. 3 divided by 3 is 1. Cosine divided by cosine is 1. So we have 9 over 125. I'm going to go ahead and write that in the front. The integral of sine square theta d theta. Now, learning from before, we know that we are going to need a trig substitution. Not substitution, but a trig identity for this one, right? So that would be 9 over 125 integral of, we're going to reduce the power, so we are going to use 1 minus cosine of 2 theta over 2 d theta. Okay, now take the integral. We would have the integral of 1/2 theta is 1/2 d theta is 1/2 theta multiplied by the coefficient in the front. We would have 1 over 250 theta minus the integral of that is sine of 2 theta over 4. So this will give us 9 over 500, okay, plus c. All right, Now, what we need to do is go ahead and simplify the sine of 2 theta, because the things that we have up here when we did the substitution has to have only theta and not 2 theta, right? So we can go ahead and use a trig identity to simplify that. So that is 9 over 250 theta minus 9 over 500. Sine of 2 theta, double angle, is 2 cosine theta sine theta plus c. 2, simplify with that, we are back to 250, right? So let's go and do our substitution. So we know that from previous here, sine theta is 5x over 3, right? So sine theta is 5x over 3, so that theta would be inverse sine of 5x over 3, and that will give us 9 over 250 sine inverse of 5x over 3, right? Minus 9 over 250 multiplied by, I'm going to write down sine first because I see it right here, 5x over 3 multiplied by cosine. Let's remind ourselves of what cosine was. Cosine was adjacent over hypotenuse there. So we have cosine of theta was square root of 9 minus 25x squared over 3. And that's what goes right here. Square root of 9 minus 25x squared over 3 plus c. We actually could clean this up a little bit so that it's a little bit nicer. 9 over 250 inverse sine of 5x over 3. Okay, let's see what's get cleaned up here. 9 divided by 3, that's gone. 5 goes into there 50 times. So what we have left is minus x square root of 9 minus 25x squared over 50 plus c. And that is our final answer for the integral.